Hi,
Good
everybody.
morning,
How are you
good
doing?
afternoon, good morning, good afternoon, good evening to everybody, wherever you may be across the world. Really, thanks for joining us live here today for Serverless Office Hours, streaming on AWS and serverless land, same time, same place every week. I'm Julian Wood, developer advocate for serverless at AWS, and I am joined today by the emitter of events, the messiah of serverless messaging, Mr. James Bezick himself.
Good to see you,
How are
Julian.
you,
How are you
James?
doing? I'm good.
I'm doing very good. I'm doing very good. Thank you. Well, today we're all talking about decoupling serverless workloads with Amazon EventBridge. And the first half, as with each week, is James dropping his guru knowledge by building some cool stuff. And then we open up to all your questions as we go through about EventBridge or anything serverless in general. But please don't hold back your questions. James is so nice and generous with his time that he's happy to take questions throughout. There isn't much that James doesn't know, so I will let him carry on with the speaking and I will bask in his knowledge and learn as much as you do.
Yeah, so today's topic is about decoupling serverless workloads with Amazon EventBridge. And so I've got a few things to show you today. And I'm going to talk about 4 different things. So basically, I'm going to start with the challenges of microservices, things that we think go well, but actually go wrong with them. And then also how we can address some of those through integration patterns with EventBridge. And then I'm going to look at how you extend your applications from the AWS cloud to SaaS providers and beyond the workload itself. And then really most of this, we'll be talking about 3 or 4 different examples I've got set up. I'm going to walk through the code and show you how you can use EventBridge patterns to start decoupling these applications. So I just want to talk a little bit about how the challenges with microservices, because they're not as easy as they might seem. So you start off with a microservice that looks like this. You have 2 microservices, an order service and an invoice service. And at this stage, everything's great. It's decoupled. Everything is very simple. But what tends to happen is that when you have a microservice that's popular and successful, everybody wants to integrate with you. And so in the case of this e-commerce example, we start to find there are more services that come along and want to talk to your service. And so that means there's more work for the order service team to do. You've got to actually find a way of integrating with each of these. And if there are any sort of backwards incompatible changes that happen in APIs, suddenly the order service team is on the hook to integrate with those too. And so over time, as this starts to develop, what you find is there are more and more and more services that arrive. And 2 things happen. One is that your order service team starts to become very, very stuck with the integration work. They're no longer working on new features. They're simply a queue managing the work for other teams coming their way. And the second thing that starts to happen is this image starts to look monolithic. Remember the monolith, Julian? We're trying to avoid the monolith.
Yep.
And so that's one of the problems with microservices, is that over time you start off well, and you start to get into a point where there's more and more friction as you develop. So that's something that I'm really interested in using events to solve. Now, the second thing to think about here, if you think about that e-commerce example, is that we often see diagrams like this, the happy path. You know, an order service talks to an invoice service, a payment service, forecasting service, and all of these things work well when they're working as they're expected. But what happens when something goes wrong? So let's say in this case you have an exception occurs, and so in this case maybe the product in this fulfillment example isn't on the shelves, and the fulfillment service has to back out a change and say, no, we weren't able to fulfill this. They send the message to the invoice service. They then turn around and send a message to the payment service, maybe to undo a payment or issue a credit. And then maybe they have to get shipping to do something because that label's already been produced and it was a physical problem, so it falls out of that exception handling. Maybe the forecasting service just doesn't accept these kind of updates, so somebody manually has to change this. And so what happens in these kind of examples is that anytime something occurs that's outside of what's expected, and this is really just this one example of many that could happen in even this simple system, suddenly it becomes really hard and fragile to make everything work. And so with that, you know, microservices are still great. I mean, there's all these different benefits that we see with them when they're implemented well. Firstly, we do see loose coupling between different services, generally speaking. We also see enormous scalability. It's one of the reasons why many AWS services are built this way, is simply because of the enormous scale benefit that we see. And often, with this kind of design, you also get extensibility. You can produce events that other teams can build their systems off without you being directly involved. You can also make projects less complex, so you're not having massive amounts of code in one service. And it can also help with availability. There are many patterns available in this approach that can help with resiliency and fault tolerance. So we want to be able to use microservices, but we want to be able to also avoid many of the problems that you see that I've shown just up to now. And so what we have is Amazon EventBridge. And if you've been following me on Compute Blog or anything I've been doing in the last year, I talk about this a lot. I think this is a revolutionary service in really helping serverless developers create a decoupled systems. And it's a serverless event bus service that really helps make events first-class citizens throughout the AWS cloud. And it can integrate events from your own applications, from AWS services, and also from SaaS partners. Now, it's not a brand new service. It came from Amazon CloudWatch events, so it already processes trillions of events every month. And the two key things that are important to know about it today are that, firstly, it decouples producers from consumers, which we'll get into a little bit more in the examples. And the second, that it handles this filtering and routing of events. So events get thrown into the bus. It decides then where they get routed to. So in a very simple way, if you imagine that previous example with the e-commerce application, what it looks like with an event bus is actually fairly similar. You just basically have the order service speak to the event bus, and then all the downstream services consume from the event bus instead of directly from the order service. And so in this model, what you find is that the order service sends events, while some downstream consumers want to receive all events, some others will want to receive a subset of those events. And so the event bus makes all that happen.
Can I just integrate? Jeepers, I sound like a serverless event bus. Yeah, there was just some crackling. There is some crackling. Andreas Grimm says he's troubleshooted it, and he says when it transitions slides, which is very good troubleshooting, Andreas Grimm. But yeah, can you just repeat the last bit you did? The other stuff, I think, apologies for some of the sound quality, but normally it's all fine. It's just the last little bit you said was a little bit garbled. Something happened to the event. It got corrupted.
Yeah, no worries. So essentially, when you put the event bus in the middle, what's happening here is the order service can send events directly to the event bus, and then the consuming downstream services only need to listen to the event bus. And so essentially, it stands between the order service and all of these downstream services. And so what's really interesting about this is it means that the order service at this point only needs to do one thing. It only needs to talk to the event bus. And actually, the team that manages the order service can be completely unaware of who is consuming those events downstream. And so it really helps decouple these services and really helps those development teams work on their services instead of wondering and worrying about all of these integrations.
How does this differ from an example where people are used to using either queues or topics, when people would do the same, well, partly the same thing? So they would put something on a queue and consume for a queue, or notify with the topics. Why is EventBridge different?
Yeah, it's a great question. So we've got SQS and we've got SNS and there's EventBridge. Now SQS is a queue. And so in this case with SQS, you put anything on the queue and then you have a consumer that will then take events off the queue. And anything that's on the queue is durably persisted until that system is able to handle the message that's in the queue. So with SNS, that is very similar in some regards because you have publishers sending messages to SNS topics and then other consuming systems taking those messages off of SNS topics. The big difference between the two, between SNS and EventBridge, is actually the type of consumer and also the routing capabilities of the service. Whereas SNS, I would say generally, is great for very large scale fan out if you're going to tens of thousands of different consumers. Whereas EventBridge is great when you're really more interested in having rich routing capabilities. And it's also possible to combine these services as well. So in my examples today, I'll show you a couple of examples where you can combine 2 or 3 of these and get some really clever architectures as a result.
Yeah, one of the interesting things I like about EventBridge as well is if you think of a topic is you've got a sort of a one-to-many relationship. You have a single message and you fan it out to lots of other people. SQS is the opposite way around, where you put a message on one thing and you have many can pull from it. And EventBridge sort of has both. It's actually got a many-to-many approach that you can have a whole bunch of different events that don't need to do anything. And apologies, I'm probably grabbing some of your slides up ahead. But
That's fine.
Larinch, I just had a comment. He says, in this case, EventBridge, is it working like a dispatcher, right? Is that a way to think of it?
Yeah, I suppose that's one way you could look at it. I think really, event buses are a model that have been around for about 10 or 20 years, I think. And originally the idea was it became this central place you could send all your events, and then it decides where they go. So there is that dispatcher element to the way it works, but there's a bit more sophistication because, I mean, originally one of the problems with event buses was that it was a source of failure, the single source of failure in the middle of the architecture. So what's different here is that this is a highly available system, so you haven't got that single point of failure issue. But essentially, its main duty is to receive these events and make sure they're routed effectively based upon the rules that you put in place.
Yeah, that's, I would say, is a better way to describe it. It's more of a router or router. So it's not just dispatching, which is the mental model of send something out, but it's a router that something comes in. So yeah, carry on, James, with your slides. You've got it.
No worries. It's all a conversation. We can chat as we go. And it's, really the other thing about EventBridge is that it retries as well. So if you have a downstream target that is not available for some reason, it will keep retrying for 24 hours using exponential backoff. So there is some smartness built into this as well. And in the event that you want more resilience than that, you can use the dead letter queue configuration. So the event eventually ends up on the DL queue, and you can process that separately. So there is quite a lot of resilience built into the way it works as well. But this slide shows these are the types of event sources you can have with EventBridge. And so there's up to 95 different AWS services that can produce events. Many of them actually already do. So anything you're using from certain services is already producing events, and they're going into your default bus, even if you're not actively using those events. And then you have custom events, which are being produced by your own applications. And then SaaS apps as well can produce events. And these are applications like Auth0, Datadog, and PagerDuty. And so if you integrate your accounts with SaaS partners, what happens is they put their events directly on their bus, and they appear in your partner event bus within your account. So it's a really effective way of passing traffic without needing webhooks and passing traffic over the internet.
So you don't even have to run a Lambda function to poll that third-party event. You just create the connectivity and the events appear.
Yeah, I mean, it's really very, very simple. And so one of the benefits there is if you put a webhook out on the internet where you're trying to get information from a third party, often you can get overwhelmed by the amount of traffic if suddenly the system gets very, very busy. And so by doing this way, you're essentially offloading the complexity of managing something like a webhook and just having the events appear in your account. It makes it a lot simpler to manage that integration. So you have these three types of event bus. Now, at the moment, you only have the default event bus in your account that always exists, and the other type are up to you to create if you choose to create them. But the default event bus is where all of the AWS events end up appearing just by default. And then the next thing, once you've got these buses, is you've got to define rules, and rules are really where all the complexity happens. So you can say in the rule that you want an event with these attributes to go to this type of target. And so really, all you have to do to make all this work is define rules. And then when you look at targets, that again is another long list of different services that you can integrate with. So the targets are things like Lambda functions or Kinesis streams or step functions workflows, API gateway, and there's many, many others. You can even send events to buses in other accounts. And so when you look at this, essentially you're looking at things that produce events and things that consume events, and then the rules in between to match one to the other. And that's really all that EventBridge does from the point of view of configuring it to do things. And what's really interesting is how you can then use this to start building these decoupled applications. So I like to look at this one. It's called the scalable webhook. So in the case of a webhook is an HTTP endpoint that's callable from another service. That could be a microservice or a third-party application. And so part of the problem with a webhook is that the third-party provider doesn't know if you're having a problem. So if you imagine having a service like Stripe or Auth0 or Datadog calling your API endpoint, you may have a problem with your system where you're not able to process those messages for some reason. And most likely they don't know that you're having an issue. So you might lose data if they're not aware of that. So this is a really elegant solution to simply create a durable webhook without really changing very much. So in this case, what we do is we've still got the HTTP API endpoint, which your third-party provider can call. And then we have those messages routed directly to an event bus. And for that, we're going to use a service integration, which I'll show in a few minutes. And then you set up your rules there to route that to an SQS queue. And then that will then route to your downstream consumer, which in this case is a Lambda function, but it could be anything. And the really interesting thing about this, and I'll show you this in the code, is that if you have a glitchy downstream process or something that's having some sort of service disruption, the SQS queue will durably persist the messages. And whoever's calling the HTTP endpoint isn't actually aware that you're having any type of problem. So this type of solution is very, very simple to put in place, but really provides you a lot of resilience. So when you look at how this actually works, we're going to be looking at building this using a SAM template. Now, the URL on the screen is where all the code resides, but I'm going to be showing you this in Cloud9. So in this case, what we're going to do is we're going to define a webhook, and we're going to use a service integration, which means that API Gateway talks directly to the service without going through a Lambda function. So in this case, API Gateway will go straight to the EventBridge default event bus. And I've set this up fairly simply, but it's not doing anything too complicated. It's simply going to take the payload of the API call and put that into the event. In real life, you could do a lot more in terms of connecting this so that you look for certain attributes and you validate data and so forth. But just to keep it easy, I'm just taking it from one point to the other. Now, once then we get to the event bus, we talked about rules. Well, what do rules actually look like? Well, in SAM, it's actually fairly simple. It's just a little bit of YAML. So in the case of this rule, what it's going to do is look for an event pattern, but the source is my webhook. That matches the source that the integration is using. And it's then going to specify a target of the SQS queue that we've created. So you'll see here that it's got an SQS queue ARN that's routing to. So let's take a quick look at how this really works. Now, hopefully, Julian, you can see this, okay?
Yeah, I can see that. I see we have full access to all of AWS. So let's start that Bitcoin mining straight away.
Great. So I've already cloned those 3 projects we're going to talk about just so we can save some time. I'm going to walk through each one. So let's look at the SAM templates, because that's really the definition of the whole application. So this is the scalable webhook. So the trick to the scalable webhook is the SQS queue, and we can define that straight away in these couple of lines here. So this is just a vanilla SQS queue. Now in our case, downstream, we're going to have this consumer function, which is a Lambda function. And what we're saying here is the code is stored in this code folder over here, and it's using a handler called consumer. This is a Node.js runtime. And it's really just a logger, so we're not doing anything too complicated. The memory is going to be 128 megabytes, and the time will just be 3 seconds. Now you'll notice I did something a little bit sneaky here. I've made it so that this Lambda function can only run one at a time. It cannot scale up. So you'll see why very soon. And we're going to have this so that it has access to that SQS queue that we defined at the top. And then the event section, we're setting this up so this Lambda function is triggered by new messages arriving in this queue. And I'm setting the batch size to be very small, just 1. And there's a reason for that I'll get to very soon. Now, the HTTP API part is really interesting. So we're going to use the new type of API gateway APIs, which are called HTTP APIs. And we're going to put all the logic in this open API specification. You'll see the location here is api.yaml. If I open up api.yaml, what you'll see is it defines this path webhook as a post, and it has the body of what was on that slide before. We're essentially taking the body of the payload going to the API endpoint and mapping that to a payload in an event for EventBridge with a source of my webhook. Otherwise, the whole detail is just being put into the event. And that's all that's in there in the API definition. And then further down in the template, we have an IAM policy that provides API gateway with the access to do this. And then there's the event rule, which we saw on the slide before, which is going to look for events with my webhook and send them on to the SQS queue. And then finally, there's another queue policy, which is just IAM. So this has already been deployed. So what does it look like? Well, if I bring up Postman, I already have the webhook URL for my deployment. And so it's just this API gateway endpoint / webhook as defined in the Open API.
Can we just zoom into that Postman, James, for us old people with poor vision?
Yeah, I'm trying to see if I can actually. Let's see.
Good point.
It's kind of
Derail the
small.
whole thing. Derail the whole thing because you.
Okay, let's see if we can make the font bigger. I'll put up the font size here.
There we go.
Okay.
Yeah,
well, you still can't see the URL.
Doesn't matter. Doesn't matter. Just
Trust me,
pretend
it's just
an API
endpoint.
gateway URL.
That's right. That's right. So that's the API endpoint we had from the deployment I did earlier, and we're just going to pass it this payload, which is just a JSON payload with my name James just there. Now, if I send this, you'll see that we get a response back. I know you can't read this, but trust me, it says 200 OK. And so that the API endpoint was called successfully, and it's passed that on. And if we go to that very end downstream Lambda function that we deployed, I'll go to my Lambda tab here. And this is a very long name, but it's the #1 Q consumer function we want to look at. I'll just open this up. Now, if this has been run successfully, what we'll see is that CloudWatch logs has been called and it's logged out the event. So we'll just go to the monitoring tab. Just waiting a few seconds here to catch up.
So how does this work, just for people wanting to understand the synchronous versus asynchronous aspect of it? Because we're obviously talking about asynchronous messaging between services, but obviously we're passing something through API gateway. So what's the handoff between the synchronous and asynchronous?
Yeah, this is something that's really important because it helps you with scalability. So when you look at synchronous calls to API gateway, these are the type where you have up to 29 seconds to get all your work done and respond with some sort of payload or result. During that time, your caller is waiting for something to happen. And so most of the time, you can use synchronous workloads just fine, but as your systems become much busier, you start to get spikes from this traffic. It's generally much easier to move towards an asynchronous model where what happens is the caller passes the request to API Gateway. API Gateway immediately responds with an acknowledgement that it's received the request, but no payload. And then the work continues on downstream. And there's some subtleties to making this work because from the caller's point of view, it can seem much more responsive, but it can sometimes be more tricky to get the payload back to the front end. In front-end applications, we use things like WebSockets as a way of delivering that payload. But generally speaking, I'd say that you want to try to use asynchronous models wherever possible.
Thanks, James. Yeah, apologies. The audio is just freaking out a little bit. I don't know if you're bringing down AWS Cloud with a browser tab open or something like that. But it just as a quick recap, James's point is about even though API Gateway has a 29-second synchronous timeout, a really good practice to use is to send something, get a synchronous response immediately, and then in the back end go and do some asynchronous processes. So this was the question I was asking, which is the handoff of you send something to API Gateway. API Gateway is going to synchronously accept that request and send it immediately to EventBridge. And then behind the scenes, EventBridge can carry on and do as many things as it needs to be, and the client is immediately going to get that response. So that's fast response from your client without having to wait, but getting the power of an asynchronous event-driven model on the back end. Was that an okay explanation?
Great explanation, better than my explanation. So it's
doubt it.
So what I'll do is I'll move on because I can tell you that it was invoked. So you can see from the graph here that that endpoint was invoked. But the interesting thing is what happens if suddenly we get lots of requests. So you remember that in my setup of this, I throttled my Lambda function so it can only run a concurrency of 1, and it can only receive a batch size of 1, which is 1 message at a time from the queue. And in my code, I also made it so there's a delay in the code where the Lambda function essentially takes a second to process each message. So I'm making it so that the Lambda function is artificially slow so I can demonstrate this. Now, to make this work, I'm going to use Artillery. So if you've never used Artillery before, this is a fantastic tool for load testing your endpoints. Now, what I can do here, if I look at my Artillery configuration, this is simply going to call the same endpoint, the webhook endpoint, but it's going to put 100 messages it's going to send 100 messages to the API gateway over the course of 10 seconds. I can just do artillery run. Perhaps I'm in the right directory. So that's now sending messages, and that's going to overwhelm my Lambda function because I've throttled it down to this 1 second per message with a concurrency of 1. Now what's happening is that all of these calls have succeeded. You see there's a 200 messages saying that they've been successfully received. Now if I go to my SQS queue and refresh this, what you'll see is that these messages are now starting to queue up. So I've got 81 messages in the queue, and my Lambda function in the background is processing them one at a time as fast as it can. But the caller is unaware that I'm having this slowdown, and if there's any sort of problem, the SQS queue is also backing me up. Now the other thing you can do here in this function, if I just move to this, I've also created a failure part of this function using a variable. So if it takes this environment variable called failure rate %, and it basically causes the Lambda function to fail, so I can inject failure into this whole thing. So right now that's set to 0, but if I then set that to something higher, like 50%, this means that every other call thereabouts is going to fail. So I wanted to build this durable, scalable webhook, but my Lambda function is now flaky. It's going to throw errors all over the place. So that now when I go back to doing the same thing, I'll send another 100 requests. What we can see is that it's still buffering these requests in the queue. And what happens is, even though every other Lambda function call is going to fail, the SQS will retain that message to ensure that it doesn't just get dropped if there's a problem. So this is a really elegant solution. It's fairly easy to implement in any existing system where you've got an API endpoint and some sort of consuming Lambda function. All you have to do is put the EventBridge integration in the middle with the SQS queue.
So this is not also just using SQS as a buffer, but also as a safe, durable storage medium. I can't just picture off the top of my head, but I mean the SQS default retention is certainly way longer than you're going to need to hopefully troubleshoot this. So yeah, this is a really good way. Dump things on SQS, and then anything that pulls from it, it's only going to delete it from the queue once it's been successful. And so, yeah, I suppose you can get yourself out of all sorts of trouble by just using SQS as a temporary data store.
Yeah, I mean, SQS is incredibly resilient. So it's one of those things where I think people generally don't use it enough. When you think about all the things that can go wrong in applications, when you're calling to other services, SQS provides that level of resiliency for when you want to smooth out traffic or you want to be able to retry messages if something goes wrong. But this kind of integration with EventBridge definitely makes it very easy to combine both EventBridge with SQS. So the second one I wanted to show you is a little bit different. So this is a method of using EventBridge to respond to workflows. So if you have some sort of step functions workflow, this can be a really useful pattern for you. So in that opening example, I showed the e-commerce example application, and it had these 6 different services. Now, some of these services, like payments, may have their own complex logic internally. So if you think about payments, that could be processing credit cards, but it could also be processing checks, things that take multiple days or even weeks potentially. And you may have issues where payments get reversed or they fail or there's credits to be issued. And so this sort of service is a really good candidate for a step functions workflow, given the complexity of what's going on in the covers. And so it's useful when you have this kind of workflow to be able to emit events through state transitions, when a workflow has started, when it's ended, when there's transitions that have happened, so that you can respond to those changes. For example, imagine that you want to be able to send out an email or take some action if a credit card payment fails in this payment service. So to do this, this is actually relatively straightforward to set up because step functions natively sends events to the default bus. It happens automatically anytime that you're using step functions. And all we have to do then is listen to those events, and then we could route them downstream to something like a Lambda function to take more action. There's also no cost involved here in terms of sourcing the events, because any events that are sourced from AWS services are free. You get those for free in your event bus. So this is just something where you set up a rule to consume those events. Now, the way this works, if you look at this is a sample event coming from step functions. Step functions tells you fairly useful things: the execution ARN, the state machine, the name, what the state is, if, when it was started, and any payload that's going through the workflow as well. So what's interesting about this is you could build an integration for a step functions workflow that doesn't exist yet, because essentially you're completely decoupled. You could build a Lambda function, for example, that always does something if a step function's result is successful or it's not successful. So let me show you what I mean by this, because this is an interesting one. So going back to my the code, I'll just close these ones down. This is the second example in the GitHub repo. And so here you've got this template. Let's just have a quick walk through the template to see exactly what's happening. So in this case, it's actually simpler than the first one. You've just got this Lambda function, which is going to be our consumer Lambda function. And just like the last one, it's going to log out events. It's not really doing anything in this example. But the really important part here is the rule. So you're creating an EventBridge rule that says you're going to be listening to aws.states, which is step functions. And then you're going to target anything that happens with that matching rule to a consuming Lambda function. And then finally in here, there's permission. You need to make sure that the permission exists for EventBridge to invoke your Lambda function. But really, that's most of the work right there. So with this already deployed, let's take a look at what happens.
So this rule is going to then grab everything from step functions that's going to happen, and the Lambda function is going to do whatever passing. But you could have a more involved rule from EventBridge to say only when a task starts running or finishes or errors out, and you could get more nuanced or whatever the term is.
Exactly. So yeah, this is going to be a fairly blunt rule in terms of just catching everything, but you can definitely be much more precise. And so this has been deployed using our SAM template, but you'll see the rule in EventBridge. Just waiting for that to catch up. These are actually the 3 different rules used in my examples, but this is the one we're talking about, number 2. And there is the event pattern saying we're listening to source of aws.states, and that's the target that's being invoked. Now, if I go to step functions, I have nothing set up so far, so I'm going to create a state machine. I'm going to just take the hello world example, that's the generic one when you first start, and I'll just define that. So it's called my state machine. We'll just use all of these defaults. So that's fine, I'm going to create that. Here in the main window, we can see it's just busily creating that state machine. So that's now ready to run. Now this is a very simple state machine. It's just the hello world example. But if I click on start execution, and we'll say, hello Julian. I start the execution now.
You're not executing me, are you?
I say hello to you.
That's much better.
It is, isn't it? And then if I go back now to Lambda, hopefully this machine is being very slow because of StreamYard, but hopefully we can get to see this. You'll see that
it does get a bit garbled when we go between the tabs, but I think everybody's getting the idea.
Okay. So what happens is this will have invoked that second Lambda function that was deployed by the SAM template. But the really interesting thing here is that the set function state machine did not exist when I first deployed the application. So that to me is a really good test of a decoupled application where you're listening to services that weren't built when you built a consuming service. That really gives you an idea of how powerful this can be when you want to listen to certain events that are happening in your infrastructure. This doesn't look like it's going to load, so I'll move on to the third example. It explains this in a little bit more detail. So another thing to think about with EventBridge, it's really powerful, is it integrates with CloudTrail. Now, CloudTrail is a service that logs lots of events that are going through AWS. They can be anything from API calls to things in the data plane or the control plane. And you can really listen to lots of different things that are happening across different services. So really, any service that logs to CloudTrail can be a candidate for listening to events that are happening in EventBridge. So this can include services like AWS Batch, Code Build, AWS Glue, IoT Greengrass, and many, many more. And you can also listen to events like sign-in events from the console or tag changes, or really almost anything you can think of within AWS itself. So once you've created a CloudTrail that is defined to listen to, to create a trail from things that are happening, you can then create these rules. So in this case, I want to listen to S3 buckets. Now, typically, when you deploy a serverless application using SAM or serverless framework, usually you have to create the S3 bucket along with any Lambda function that is listening to events in that bucket. I think serverless framework has a plugin to get around this, but it's a little bit awkward sometimes if you're not owning the bucket directly that you need to be listening to. What this enables you to do is create applications that listen to buckets generally. So in this case, in this example, we've got these sales buckets. You can imagine they collect sales reports with the pattern my sales Jan, my sales Feb, my sales March. Now, what I want to do in this application is I want to listen to events from all of these buckets. One of the limitations of using SAM to do this normally is that you cannot create subscriptions that are overlapping. So if I have two different Lambda functions that want to listen to the same bucket, but they've got exactly the same prefix or suffix, that can't happen because you can't have these overlapping subscriptions. In this model, you're actually decoupling that whole thing where your application is listening to EventBridge, not to the S3 bucket. So you can do some more complicated types of overlapping. So once you've enabled CloudTrail, what you then do is you enable the EventBridge rule to define which bucket events should then trigger the function. So in this case, you've got an event pattern that listens for put object events, and that will then define these bucket names of my sales, Jan, Feb, March, and so forth. And then you can modify the behavior of the Lambda function that's triggered simply by modifying the EventBridge rule. So what you can do is you can take this a step further by using content filtering rules in EventBridge rules. And so imagine that you need to invoke a Lambda function when an invoice is saved in these monthly sales buckets, but the April bucket doesn't exist yet, the June bucket doesn't exist yet. So when those buckets are created, you want your application to still work. So using the native S3 to Lambda function, that is event source mapping, that only allows you to map functions to existing bucket, but this approach gives you a dynamic mapping to map events to buckets that really could be any naming pattern that you choose. Also, CloudTrail logs additional event information from S3, such as object size, principal, source IP address, and many other different attributes too. So you can filter on any of these attributes and using complex rules to create any type of event that you really want from S3. You can also then route these not just to Lambda, but to step functions or any other service that's a target of EventBridge. So let's just have a quick look at this one to see how this works. So I'll go back to Cloud9. So here's the template. Now this is a bit more involved because we're using CloudTrail. So I created a SAM template that also creates the trail. When you deploy this, it asks you for a source bucket name and also a logging bucket name, which is needed for CloudTrail. So what it does is it creates these two buckets. You'll see these defined at the top there. Then it uses this bucket policy, which is what allows CloudTrail to listen to events on those buckets. It's kind of a long policy. Then a bit further down, this is the trail itself, which then depends on the policy being created first. It defines the logging bucket. And it says what type of events we're listening to that we want to have logged. Then finally, down here, we've got the Lambda function. This is the same logging type of Lambda function we've been using before. It just receives the event and logs it out to CloudWatch. And then finally, here's the EventBridge rule. So here I'm saying I want to listen to events in S3 that are of a put object type. That's when any time that an object is written to the bucket, and I'm listening to that source bucket that I defined. And then there's the target. That's the Lambda function that we defined, and then some permission. So the net effect of this is I've got in S3 this bucket I set up called EventBridge source JBezwa. That was deployed by my SAM template when I deployed this earlier. So I'm now going to upload an object to that to trigger the rule and then trigger the Lambda function. So what I'll do is I'll just go into there, and I'm going to just create a test file. And I'll use the CLI to copy this across. So I'll say AWS S3 CP test file. Oh, that's the wrong one. I need the bucket name before. No, I don't remember it. Let me just type that in again. AWS S3. It's EventBridge source JBezwer. This will copy that object up to the S3 bucket. And if I go back to the S3 and refresh, you'll see that that object is now there. There's the test file. And what that's done is that's then, the action is that that's then triggered an event to be written to CloudTrail. EventBridge is listening to CloudTrail using that rule that we created, just saying anything that's put into this bucket triggered this rule. And that then triggers the Lambda function at the end of this whole thing. And I think if I can show you that, we'll try. If Lambda, see if the console is responding.
So what does CloudTrail actually send to EventBridge? Is that the location of the S3 object, or is it the object itself? What is the sort of, what are you actually passing between all these services?
Yeah, it's a very good question. So when you get any type of event notification being passed through either directly to Lambda or through EventBridge, you're being given the metadata about the object itself. That involves the bucket name, the key, the principal, time and date, the size, a variety of other different attributes. So it's important when you receive that event, if you want to do something on the object, such as load the object or transform it some way, you need to actually load the contents of the object directly using your code, because that's not what's being passed to you.
So James, I'm just going to summarize because the audio is garbling out as Lambda spins around. So yeah, James is just saying that it's actually the metadata that gets passed around, and then you need to you'll receive the location to the object, and then you can use code within your Lambda function or whatever other service you're going to do to actually grab the object.
Yeah, exactly. So that's going to keep spinning. So this is proof that everything fails all the time. So that's why we want to have resiliency built into our systems. And so I've got my resiliency in the form of Julian. But yes, if you look at those three examples, the key pattern between them is really to build things where you are focusing on using EventBridge to build one side of the problem. So essentially, the thing that produces events may not exist yet, or you may not have access to, but somebody's producing events that end up on the event bus. Then you're building an application that consumes from that event bus. Now, what it means is that you can do some really interesting things from the point of view of designing applications. So I'll show you a few other things that are interesting.
James, once you switch over, I've just got a question here from Jim McDonald. Any concerns with creating an EventBridge rule that's watching a pretty chatty bucket? Let's say, for example, getting 100,000 objects loaded.
Yeah, and this is actually one of the great things about EventBridge is that if you have a rule that filters down to something very specific, if you're interested in just one bucket but with a prefix of James and ignore all of the other objects, even if 1 million events are being produced by that bucket, and you're only being invoked once as a result of this rule, you're only being charged for that one invocation on Lambda. And because the source of the events is from S3, EventBridge isn't charging you for the event production that's going into EventBridge. The thing you have to watch for, of course, is CloudTrail, because CloudTrail, if you have a really, really busy account, you can create gigabytes of logging data. So you want to make sure the CloudTrail, when it's defined, is as specific as it needs to be about what type of events that you're watching for.
I mean, the bigger picture is EventBridge is created for unbelievably massive scale. And the thing to remember is that it's not as though your Lambda function is going to be polling every message that goes through EventBridge. It's only the rules that are going to match. Any rule that doesn't match is just going to get dropped from EventBridge. So you don't need to worry about overloading your downstream systems. Any rule that's not matched, it just gets discarded. So you can, in fact, have a rather chatty EventBridge buses, but if not many rules are working, that's still going to be fine. And EventBridge is built for massive scale because EventBridge came out of CloudWatch events, and CloudWatch is a massive service that literally runs monitoring, observability, logging, tracing, and logging. Sorry, not tracing, for all of AWS and Amazon.com as well. So this isn't a new service that we're slowly ramping up to try and make sure it's got the throughput. EventBridge certainly has the throughput from based on its origins.
Yeah. And so when you put this all together, I'll show you one of the things I think that's really interesting. When I first started using EventBridge, a lot of this was very new to me, and so I learned how useful it could be by applying it to existing applications that I'd built. And so I find it really helpful to use EventBridge when I'm using SAM to build my applications. And so you can decouple applications much more effectively when you put the two together. So SAM is an infrastructure as code tool that transpiles down to CloudFormation. So all it's doing is it's providing you a shorthand for serverless resources that's more convenient as a way of building things. But when you run SAM deploy from the command line, it's building CloudFormation that then deploys into your account. So there's a few benefits of using SAM that are worth thinking about when you're building bigger applications, especially when you're bringing in EventBridge. One is simplicity. You can build smaller microservices that communicate using events with each other, and that really helps make the code that you're putting in each application smaller and more simple. Also, if your application has different teams working on different components, it makes it easier for different teams to work on different sections of the code, because you can each control one service without needing to know implementation details of each service. SAM can also make it easier and faster to deploy because it is an infrastructure as code tool. So you're not going through the console clicking, where it's easier to make mistakes. And also, it helps you with this extensibility problem. And I'm really interested in this because so many projects I've worked with, with corporations, you end up building features onto things as the application becomes adopted, things you'd never thought about in the first place. So building for extensibility helps make your applications just that much more useful to your customers. And I think it also makes things easier to understand. So to show you this, here is an example application where I used this approach. So in the first version of this was a SAM monolith. It's one application with everything in it. It's got resources for Lambda functions, S3 buckets. It uses recognition and a whole bunch of other things. What it does is it listens for types of content arriving in a documents bucket. It extracts content and text from those documents, from PDFs, Word documents, images, and so forth, puts them into other buckets, which are then queued up to be put into Elasticsearch. And so the idea of this is a document repository system that could be used by a company for large numbers of documents. And this is great, but the problem is, if I then come up with a fourth document type, it's actually problematic because I have to create a new consuming Lambda function. I've got to integrate it with this whole thing and redeploy the whole application. So if I instead take this approach where I use EventBridge and SAM, this is how it ended up looking by comparison. The URL at the bottom shows you where you can look at these applications. But in this new design, instead, I simply had documents buckets, and then each file type became a generic type of function that was consuming an event from EventBridge, which makes it easy for developers to then create new converters for different file types without impacting the design of the existing system. And while the loader function that pushes the data to Elasticsearch, if I want to change where I'm indexing data in the future, all I have to do is change the rule on EventBridge to where that data is going. And I can then integrate with any database or indexing service that I choose. And so by converting this application to being event-centric, I can really simplify the logic flows, make it simpler to understand, make it highly decoupled. And so by splitting that application into these SAM deployable microservices, it also makes it faster and easier to deploy and for other teams to then extend this functionality over time.
Yeah, I always think that's my mental model of always thinking about EventBridge is this kind of extensibility. And I like the way you've drawn it over here, that they sort of move along in a flow up and down like that, because yeah, there are going to be so many kind of scenarios where you even need to migrate from something to something else. Well, EventBridge, you could just have a second rule. So you could have a whole pathway that's going, for example, for that loader function to Elasticsearch. You don't want to touch that. You don't even want to do a migration. You're not quite sure how it's going to work. Well, just add another EventBridge rule, which goes to your second kind of function, your second whole part of your application. And then when you're happy, you can easily migrate things over, run them in parallel for a while. It really sort of opens up some more interesting possibilities.
Yeah, I think this is a really good example for the enterprise, simply because, in jobs that I've had in the past, you wouldn't necessarily have access to create buckets, or you were creating applications that worked across lots of different buckets. And so having this kind of decoupling that goes on makes it much simpler to be able to build applications that are smaller in code, but are much more flexible and more powerful to be able to do what you need. Now, one of the other things to think about with event buses, 20 years ago when this first started with event buses, it was a problem. Because when you think about the sources of events, you end up having to keep track of event structures. And so different applications, whether it's AWS or our own applications, produce events. And as people change versions of those applications, they upgrade events and add new attributes and change things. And so it becomes a little bit tricky in your application to make sure that you know what an event looks like. You may have well-defined ones like AWS events, which generally don't change. But if you're consuming custom events, then sometimes those might change depending on what those developers are building. So I wanted to just talk to you about the EventBridge schema registry because it's a really cool feature. This allows you to have a system that automatically listens and detects types of events that are going through your event bus. And so here you can find schemas for events that already exist from AWS services. So if you want to know what an S3 event looks like, for example, you could find it there. Or you could generate events that it will then monitor and then convert into registry consumable events. And so this is completely automatic once you turn it on. And then you can then integrate it with VS Code or JetBrains as well. So this is what it actually looks like. This is only a screenshot, but it gives you an idea. And so in this screenshot, you can see an example schema. And so the schema registry has identified a version for this event. And then if I then want to build an application that consumes this event, all I have to do is click the button that says download code bindings. Now, after you download the code bindings, here I'm pulling it into VS Code. And this works for type-safe languages like Java, Python, or TypeScript as shown here. And so then you can immediately use classes that are automatically created to start building your applications. You don't have to start writing boilerplate. It's already done for you. And you can start focusing on your business logic.
Yeah, and the nice thing I like about the schema registry as well is it's something you can also. It's not expensive at all for a small amount. And I think you get a million free a month or something vast number like that. But the cool thing is you can turn on that schema discovery in your dev account. Sort of as your events pass through, you get their schema, you then do it in your code, and then you can upload it to your, the whole application to your production account. You don't necessarily have to be watching the schema that is flowing through your production account and seeing all of those events going through your event bus. So that's one cool way. And the other way is also to look at events that are going through, because sometimes you're not quite sure the data that's flowing through your application. That's a bit strange. Do we understand that? Is this something strange? Has a third party changed their schema format? What's going on? And so you can also use the schema registry in a monitoring function on a production account just to see how the format of your data changes over time.
Yeah. So when you put this all together, I just want to recap a few of the things from these examples today. So, EventBridge can really help you decouple your microservices, especially as they start to grow. And you can use the event bus to separate event producers from event consumers, which can help you pass and route messages using a service instead of custom code. It helps with scalability. So scaling up and down automatically with traffic is not something you have to manage with EventBridge. It just happens in the background. And you can use this then with other services like the scalable webhook. So that gives you a pattern for resilience behind an HTTP endpoint. Extensibility I spoke about. I really think this is an important part of when you build applications today. You want to be able to produce applications that emit events for things that have not been written yet. So maybe it's your team or other teams that enables people to build things on top of your application more easily without you having to change your code. And then I think we talked a little bit about security, but security controls over EventBridge are very granular. So you can set very precise permissions over who can access the events and on which bus. And if you look through some of the code examples, you'll see where I've done that in my SAM templates. And then finally, if you use SAM with all of this, I think this can really help accelerate deployment for your applications. So you can use SAM to break apart larger applications that get to be fairly unwieldy into much smaller microservices that communicate using events with EventBridge. And all of the examples from today, all of the different URLs on the screen, I've put together a resource page where you'll find all of these. It's on the URL on the screen now, which is s12d.com /coupling. That's a landing page on serverless land that has everything from the 3 examples through to other documents and resources you can use to learn about these features.
James, that is fantastic. Thank you very much for all your super knowledge. We've got just some questions that have come in. Let me look at the. Let me just bring up this one over here. So this is from Kakumanu. Thank you very much for your question. And that was James's second example. We can directly configure Lambda as an event listener on the bucket. What's the advantage of going through CloudTrail? And James was saying the reason for that is you can normally only connect one single Lambda function to an action on an S3 bucket. This is a way of decoupling it. And so you could, first of all, James's example is not even knowing the S3 bucket names. You could have a prefix of sales data or whatever without knowing the months. And it just gives you some flexibility that you can, in fact, have a sort of generic Lambda poller or Lambda reader for your S3 kind of stuff. Thank you for your question. I've got another one from Jim. And Jim, I hear you. I also was curious why Sam doesn't allow a destroy. Yeah, that is correct. But what you can actually do is you can just do I did have it up, and of course I've lost it. You can just do a CloudFormation -- destroy. Where did I have it? I actually had it up. There we go. CloudFormation delete stack in the stack name. I'll pass that question in. I'll pop that in. But yeah, we'll put that on the feature request of the team, and hopefully that'll sort that out. So
yeah, I'll definitely +1 that. It's a very good question.
Yeah, and then the last one there was one from Bradley Jinks about is it always best practice to use SQS between EventBridge and Lambda?
Well, it's a great question because it depends on what you're doing. I mean, if you need to have the durability of messages that just simply cannot be lost, if you have things like credit card payments or transactional data that must be persisted, I would recommend you use SQS because it just gives you that type of durability very easily. However, if you have an application where it doesn't necessarily matter, if having events occasionally not be processed downstream is not so sensitive, then you don't need to do that. It really depends on the need of your workload. So, like Innovator Island is the theme park example where we publish out ride waiting times to a front end. Those come from events through EventBridge. Now, if one of those ride waiting times doesn't make it to the front end, it's because something goes wrong, but it picks up the next one. It may not matter so much in this use case. But if somebody's removing money from their bank, you want to make sure you absolutely get that transaction. So I think it's one of those things where you just decide on a rule by rule basis whether that's something you need. And it also gives you this smoothing effect as well, because when events come into EventBridge, you'll find that it scales up very quickly, and Lambda scales up very quickly. If you need to go to smooth out the traffic because maybe you're talking to downstream resources, like a database that cannot stand that type of scaling, then SQS lets you do that too. So that's another useful feature of putting that in the middle of the two sides.
Excellent. Thanks, James. Another question, which was about EventBridge itself. What is the typical latency from source to target? Now, there is a latency within EventBridge. It is around half a second, but I know that is reducing. So if you're requiring super low latency, then SNS is probably a bit more of your friend, because that has got, I think that's 30 milliseconds or something like that. But that's the latency through EventBridge. If you then are tacking on a Lambda function and you're doing a whole bunch of computation and then sending out, that latency is obviously going to be within your Lambda function. But again, with all things AWS, everything gets better, bigger, faster, more cheaper over time. So yeah, currently that is half a second, but I'm sure that's going to be improving.
It has been improving. Yeah, I know in the last year there's been a lot of work to bring that down. So I'm excited to see. I suspect over time it will become as fast as SNS.
Yeah, possibly last question. We'll see how we go. How about multi-region support for EventBridge?
That's a good question. I think it's something I definitely pass on to the PM team. One of the things that Julie and I do that many people are not aware of is that our PM teams only build what you ask us to build. So if you ever have an idea like that, just let your local DA know, and we'll be happy to go and represent that in the PM meetings and get it on the product roadmap.
Yeah, so absolutely, we'll send that feedback. But EventBridge is a really good service to think about in a kind of global deployment, because it is a really nice way from decoupling, where you are maybe sending events between regions or sending events between different parts of your application that may be in different parts of the globe. And yeah, EventBridge is a really good service. I hate to say, James, our time is up. Our
Oh,
expert at eventing has dumped as much of his knowledge as he can in an hour. We could carry on forever. So, James, I really appreciate your time. How can people get hold of you on the interwebs?
yeah, I'm really interested to know what you're building and what you need from EventBridge and how it's going. So definitely reach out to me. I'm on Twitter at JBESW. I'm also available on LinkedIn, and you can reach me at email through Amazon, which is jbezic@amazon.com. But any of those paths, I'm happy to talk to anybody about anything to do with serverless. So feel free to reach out to me anytime.
Thanks, James. And I've just realized today, I can't believe we chose the same designer for our, we coordinated wardrobes too much. So, I can't believe Dior or whoever we picked chose us the same thing. That's humiliating. But thank you so much for your time today. We'll be back same time, same place next week to talk more things about serverless. Enjoy the rest of your day and have fun building serverless applications. I'm Julian Wood. Send us any questions you have. We'd love to help. And yeah, good luck and have fun with serverless.
Thanks, everyone. See you later.